it. We are live. I am also sharing the live link in your pre-session group in case you like to share with people. YouTube is more preferred nowadays over Zoom. That's my experience. Okay. So if you both are ready, we shall start. And I will request Shankar, in case when I'm speaking for first 2 minutes, if there are people, please let them in. You have the rights to do that. Okay? Yeah. Thank you.
Sure.
Warm greetings. On behalf of W for W Foundation, a think tank instituted as Citizens Collective, we welcome you to another session of Wednesdays for Water. The conversation today is on water in the Himalayan region. Before we get into the session, a brief overview of what is Wednesdays for Water doing. The objective of Wednesdays for Water is to engage in conversation with water experts, grassroots practitioners, policymakers, and youth to explore the complex intertwined issues associated with water and the possible solutions our speakers are working upon and seeking for. With the success of Wednesdays for Water, we have crossed 200 sessions actually, but initially already with its success, we had to expand our water conversations to Friday Waters, which includes water arts, water talkies, water thesis club, water maestros, so basically looking at the legends and looking at water reading club, inviting authors. And we recently concluded our Monday Munching and Musing with Women for Water. All put together, these 3 online sessions have actually crossed more than 450 sessions and making us the longest water conversation ever taken place in the history of water education. We are extremely proud of it. And at this moment, I would also like to thank our ex-speakers, amounting to around 700 of them, and nearly touching 7,000 of participants who have attended our sessions. It is increasing every session because we are seeing digital fatigue. Nevertheless, the sessions are all available, open access for everyone to get water educated at any point in time at their leisure at www.wforw.org as well as www.forw.in. We have 2 homes right now as we are in transition to make it an institution. At W for W, we strongly believe water conversation is the only way towards water conservation. In today's session, it's not new for anyone the way Himalayan region is facing a lot of issues, from its glaciers to floods to rivers and many other ecological and social aspects. And to discuss some of these aspects, not everything, we have Water Anxiety series, and the speakers for today are Dr. Renji Remisan and Shankar Borua. Before we start the session, big thanks to Shankar to actually help me organize this session. And we will have our first speaker as Dr. Renji Remisan. And before I invite him for the session, a brief overview of his biography. Dr. Renji Remisan is an associate professor at the School of Water Resources, IIT Kharagpur. He is a hydrologist whose research centers on hydrological processes and their intricate interactions with water, atmosphere, and landscapes across present and future climate and land use scenarios. With a water research background and working experiences with esteemed institutions, many of them, I'll put it in the chat box, he has led major projects addressing water and land resource challenges. As a fellow of the UK Higher Education Academy and recipient of many notable awards, again, I'll put it in the chat box, his contributions have been widely acknowledged. His research team focuses on river and reservoir management, estuarine modeling and dynamics studies, water extreme like floods and droughts, climate change influence on the water resources, as well as catchment modeling and water management strategies. Thank you so much, Tenzi, for agreeing to do this session. Looking forward to hearing from you. I had the privilege to look at your wonderful presentation. Let's go for it. Thanks.
Thank you, Manasi. Thank you, W for Water Foundation, for this invitation. I hope you can hear me clearly. Yeah. So I will
Yes.
just go to my slide so that in today's session, I'll be talking about this topic. As Mansi already mentioned, the Himalayan hydrology is changing. So I'm going to tell you how that is changing. So I'm Renji Rameshan from School of Water Resources of IIT Kharagpur. As you already know, Himalaya is actually very, very important part of our country. Most of the countries, you can see that where the position of Himalaya. So especially Hindu Kush Himalaya is considered as Asia's water tower because of obvious reason in supplying water to many rivers. And we also call it as third pole of our Earth because of the large quantity of glaciers and ice outside the polar region. So that's why you can see this region. So the countries also, we normally talk about the rivers flowing through India, but more than almost 10 major rivers are actually originating from Himalaya. I'll talk about it. More than that, almost 250 million people are living in this area, and almost 1.9 billion people in all the countries together. They are actually depending upon water from Himalayan region through getting through different rivers. So so that region is very important. So because of climate change and man-made reasons, a lot of changes are happening. So I will just talk about those changes briefly. As you know, this is our region. We normally call it as the whole region known as Hindu Kush Himalayan region. For Indian point of view, this rectangular area we divide into three major sub-regions. The western region we call it as Northwest Himalayan region or Karakoram region, and also the central region is actually we call the central Himalaya region, and we also have a southeast Himalayan region or Tibetan plateau region. So if you look into this region, and these all region are very important for in terms of biodiversity. Totally distinct diversified biodiversity is there in these all regions. And also from these all parts you can see major 10 rivers are actually originating. I will talk about those rivers name. And from India's point of view, our monsoon, we are still a monsoon driven economy, you can say. The monsoon is actually its spreading of monsoon and its direction, etc., are largely dependent based on this position and the Himalayas position. So that's why it's very important for us to know what is happening there, and the changes happening over there because of climate change also very larger issue. So I will just talk about what is happening there in terms of precipitation. This is actually a data published in 2020. If you look into the data of last, you can see 1951 to 2015. You can see the precipitation. This is actually, this all color is corresponding to decadal change of and precipitation trend anomaly values. You can see the precipitation actually. Normally, we say in India, global because of climate change, the annual precipitation value, rainfall value is going to be increased. But in the Himalayan region, it is not the case. You can see some area it is increasing, some area it's decreasing. And also, if you look into the last hundred of years, you can see that the trends are actually very different. So because I'm talking about the annual trend. I'm not talking about the winter time precipitation. Winter time precipitation is very important in glacier dominated region because that is what converted into snow. That is what actually leading to glaciers and deposition, etc. So I'm talking about the in larger annual value. So this is the thing happening in case of precipitation. Because of this differences in precipitation in Himalayan region, different basins, glaciers, snow melt, etc., are changing, and the monsoon rainfall also changing hugely over there, and the water availability is getting affected. As you know that in Himalayan region, mountain springs, we normally called as nalas or dharas. This is actually considered as major drinking water source. These all actually getting affected because of the changes happening over there. Connected to that, even groundwater recharge, stream flow, etc. So in that way, you can see that the Himalaya is actually a glaciers and snow melt, seasonal melt over there is actually incredible part for water availability and water security of the country, especially our country and many other countries too. So the 10 major rivers, we normally talk about these three major rivers that is flowing through India: Indus, Ganges, Brahmaputra. If you look into this China, for China also Yellow River, Yangtze River, and other rivers which is going up to Central Asia, you can say Mekong, Salween, Irrawaddy, Damodar, many 10 major rivers are there. These are very massive rivers. If you consider the water availability and the population over there, almost 24% of the world population is depending upon the water from the Himalaya. It's not only India, all the countries you can see, which is actually flowing up to Central Asia, you can say, and also you can say this Mekong Delta region. It's going up to northeastern part also. So you can see this. That's why this is very major. That's why the third pole word itself is making more sense. So just for your better understanding, you can see we normally talk about Ganga and Brahmaputra. Only a small part of Brahmaputra is actually going through India. But if you look into all other river basins, these old rivers actually, which is extending up to Central Asia, is actually from Himalaya. So we normally don't know the significance of Himalaya for the world population. 24%, more than 24% of the world population is actually depending upon the water from Himalaya itself. So this is the reality. But some of the studies actually climate. Now I'm going to tell about what is happening there in terms of temperature, in terms of precipitation, in terms of snow. These are actually data. These left side panels are talking about annual data. Right side panels are talking about the winter time alone, because it's a glacier dominated region. So winter temperature is very important. And I am showing this data, which is actually observed data also there, and also predicted data up to 21 2100 year. So that means up to 80 years from now. You can see this, how the temperature is changing. All the you can see this historical value also. You can see this green line is historical value, that is measured value, and different scenarios also there. 2.6 RCP 2.6 to RCP 8.5 scenarios are there. So I hope you understand what is climate scenarios. This high emission scenario is called as 8.5. Optimistic scenario we called as 2.6. 4.5 and 6 are like middle. So that means if the emission is relatively moderate, what would be the temperature, what would be the precipitation, what is that snow, etc. Is actually, this is predicted values from the climate models. And also, if you look into this data, it will be very interesting pattern you will be seeing in this. Most of the models are saying in all scenarios temperature is increasing, and annual temperature also increasing, winter temperature also increasing. In case of precipitation, normally climate models are saying that in India precipitation going to be more, but that will be only during the monsoon time. Other season there won't be many precipitation, but monsoon will be very harsh, there will be more flood. Other seasons rainfall will be less. If you look into this in Himalayan region, the winter time precipitation is going to be relatively stable with very small marginal increase only. But in the same time, because of the increased temperature, the snow melt is actually going to be very large in coming years. That is actually the real situation predicted by many models. If you look into the numbers, you can see this is actually these are climate models called CMIP 5. These are relatively old scenarios. Now CMIP 6 data is there, which is also showing the same trend, but I am focusing on bit old data that is actually published in 2015, 16, 2020 time. So you can see that the temperature in Hindu Kush region or Himalayan region, at least 2.2 plus certain numbers temperature is going to increase up to that level in near future in comparison to pre-industrialization time. So that is actually in the 4.5 scenario. 4.5 scenario means medium emission scenario. This itself is showing that temperature is going to change large. This is a significantly large value. And again, if you think about um, winter time, you can see that in winter time the temperature is actually relatively high also compared to long time average. We can see in the winter time temperature also going to increase. Especially, I'm talking only about this middle scenario 4.5. In case of worst case scenario, it will be much more than that. But even middle scenario, I'm focusing because we are assuming that that is what we are going to experience in real. This is actually middle scenario. This is actually very pessimistic scenario. It is very worst scenario. So and if you look into this Himalayan region, it is not uniformly happening everywhere in same manner. If you look into the western region, at least 1 degree difference between the Western Himalaya and the Eastern Himalaya, the temperature differences. So Western Himalaya will be going more warmer than Eastern Himalaya. So this is also some climate models are talking about. These are the things which is actually we are going to expect in future. This is actually people are more worried about how water availability going to change. And I mentioned earlier, an annual precipitation in India is expected to increase. That's what most of the models are saying, but it is not going to be same in case of winter precipitation. Winter precipitation is actually converting into snow. So winter precipitation going to be relatively same or very moderate increase only going to happen, or even in localized pockets. So for you to understand better understanding, this is again a study published in 2014. So if you look into this, we can see this study is conducted focusing on all glaciers, almost 9,040 glaciers in India, covering this much area, and focused on a study from 1960 to 2000 period. You can see most of the glaciers are actually receding. Most of the glaciers are receding. In 40 years time, you can see some of the glaciers, the toe region of the glaciers, some portions it has receded up to 600 meter. The toe is receding, that means the whole glaciers are receding. So you can see from the color, most of the glaciers are receding, but there are some pockets where this advancing also happening. Don't assume all glaciers are disappearing, some glaciers are growing. So but that number is relatively less. So this figure will tell you how much area already lost in 40 years of time. You can see this, most of the data is showing that almost 10 to 40% is actually the aerial wise it's declining. So in some of the glaciers up to 61 meters receding, that means that it is retreating 61 meters, the toe region is retreating up to 61 meter in certain places. That is very alarming situation. So but some studies, these are actually some of the outputs are from satellite data, some in situ, that means going to the field and collected data from 2014 and 19. That analysis also showing that the retreating of the glaciers, which is leading to up to 4.45 to 1.37 meters of water equivalent. That means that much water, snow is actually melting every year. That means indirectly the glacier snout region is actually receding 13 meter to 33 meter per year. That much. I'm not talking about any particular glacier in general. So this is actually a alarming situation. Glaciers are disappearing. We have measured evidence in front of us. These are measured evidences. And if you look into India and the Himalayan region, this is an anomaly data. That means a long time average in comparison to long time average from 1951 to 2016 data. Look at this data. After almost 1980s, the temperature is increasing in mainland India and Himalayan region. Most you can see this comparison in comparison to long term average. The temperature is increasing, and the increase happening in the Himalaya is more than even that of mainland India in comparison to long term average happened last 200 years. You can see this. This is a serious problem. You can see the temperature is increasing, and the change is happening more in Himalaya than in India in comparison to long-term average in those places. Okay. Similarly, if you look into the Himalaya, there are like different elevation, altitude, etc. there. So in elevation wise, if you look into, there is also huge changes in high elevation region where more snow glaciers are there also temperature is increasing. So if you look into this data, you can see that from 1901 to 2014, in general, 0.1 degrees Celsius per decades temperature was increasing. And if you look into 1951 to 2014 time, it was certain area, it was 0.2 degree per decade is temperature is increasing in the Himalayan region. It's a very serious concern. And if you look into that high altitude regions, in certain high altitude regions, up to 0.5 degree per decade also they have noticed, but not consistent. But this is also is related to the elevation dependent warming is happening. So these are the outputs some studies are talking about. This is very concerning thing. So this is a general idea, but it doesn't mean that everywhere it is going to make same impact. For example, in India, we have two rivers. One is Indus. Many rivers are there in larger Indus Basin, western part, and eastern part we have Brahmaputra. In China, they call it as Yarlang Sangpo, right? So if you look into this river, Brahmaputra, only 34% is actually coming from the snow melt. In Indus, 66% of the water is coming from snow melt and glaciers. So if these glaciers are going to melt, these rivers, all river basins are going to have a different kind of experience. It's not uniformly going to happen in every river basins. So in Indus, it will be impact will be more. If more warming happens, more melt will happen. So more melt means recently we will be having more flood. So in long term, there won't be any glaciers to melt. Then we will experience drought kind of a situation. So this is what people are worried about, and we are hoping that this is what going to happen, or we are trying to stop it. So how much river flow is going to change in Himalaya? It's not a uniform everywhere. Even within the Indus River basin, there are many small rivers. There are Bias River, Satluj, everything is there, right? So all will be having different impacts depending upon the glacial loss going to happen. See, this is what actually studies are showing. And connected to this, as I mentioned, most of the Himalayan region is actually spring. Mountain spring is actually people are depending on mountain springs. So for example, 5 million people actually, there are 5 million mountain springs in India, we consider. Out of that, 3 million is in Himalayan itself. Out of that, 60% of Himalayan population is purely depending upon the spring water. They are not getting water from rivers or spring water. And that means almost in 12 Himalayan states, 50 million, more than 50 million people are actually depending on spring water. This is actually getting diminished because in over the time. So these are some studies recently reported, especially from the Niti Aayog in 2018. They have reported that almost 50% of perennial springs in Himalayan region are either dried up or in a near decline. 50% is actually happening. Out of that, 60% is actually happened last 2 decades. So I'm talking about a data published in 2018. So that means after 2000 itself, many decline is happened. These are actually going to put a lot of challenges over there. These all connected with the climate change also. Don't think climate change alone is the reason. The major reason for declining of springs are connected with the deforestation, without really looking into the without respecting the terrain, changing the land use, unplanned construction, and again rainfall pattern, recharge, etc. These are the problems over there. So don't think that it is only Himalayas problem. This is actually almost all 19 major regions are there in all around the world, apart from the polar region. Everywhere the problem is almost same. This is actually showing the glacial mass change and how much elevation because of the melting changing in all around the world. We are here, so ours are compared to Himalayan region, other places having more problems, but Himalaya is actually going to it's right now catering water supply for almost 25%, 24% of the world population. So our problem is going to impact more people because we have more population in this region. So don't think this is only Himalayas problem. All around the globe it is happening, especially in the Himalayan connected with the glaciers. So you know about the Paris Agreement, right? Paris Agreement, we are trying to cut down, we are trying to stop warming by at least 1.5 degree from the pre-industrialization time. If even if that is going to happen, even if you try to achieve that Paris Agreement goals by 2100, that means from 80 years from now, some studies are showing that at least 40% may be getting lost. If the temperature is increasing 3 degree in comparison to pre-industrialization time, 75% of the glaciers reserve in Himalaya may lost. And if it is going to more than 4 degree or close to 4 degree, 80% of the reserve may. These are modeled studies. This may happen, may not happen, but largely these evidences are showing that this is a seriousness. Even if you try to achieve our Paris Agreement goal, we already I have shown some of the data. We are losing a lot of glaciers. Retreat is happening. 40% may get affected. I have shown the references here. So this is another graph for you to understand the same thing, whatever I mentioned, how this is actually different seasons. DJW means December, January, February. That is actually for 40 years of study. This is again study done in IIT Kharagpur. So you can see this is not happening uniformly everywhere. So especially in spring season, March, April, May is the spring season, we can say in India. We can say in Himalayan regions, that time more snow melt is happening in comparison to other seasons. So this is for you to understand grid scale value, grid level. If you know these locations, you get a rough idea how much snow melt is happening. This is snow melt data for different seasons. This is actually temperature change in different seasons. This is precipitation change in different seasons. Focusing on our ISM means Indian summer monsoon. This is actually East Asian summer monsoon, which is actually the monsoon in China where they normally get. So depending upon these seasons, how these are changing in Himalayan region. So this is actually the whole Himalaya. So you can understand how much it's changing in this region. So by this, I wanted to conclude that Himalaya is actually, we normally consider Himalaya as a stable snow ice buffered system, but slowly, because of climate change and all, some of the river basins are slowly changing from the snow dominated region to a rain dominated hydrological regime, which is actually going to make a lot of water management challenges. And we have a lot of empirical measurements and climate model data, which is actually supporting that long-term changes in this region is happening. So we need to have better policies to focusing on the data to manage transboundary water management. We should have better spring conserving programs or water recharging programs or water resilient infrastructure to deal with this kind of problem. This is actually my observation from whatever the papers I have read. So thank you. These are the papers I have taken for whatever I have mentioned here. Thank you very much. If you have any questions, I am happy to answer.
Thank you so much, Renzi, for this overview and also alarming us, but at the same time giving an overview of the world, saying, I think the most impactful line for me, maybe it is not that affected in as comparison to the world in terms of glacier, but in terms of population, probably it is the most hit because has the majority population there. We will have more questions and suggestions and comments from all the participants. You are encouraged to put your questions and comments in the chat box. And after Shankar makes his presentation, we will also have your digital hand raised so that you can directly interact with our speakers. So I will now invite Shankar. Before I do that, I would like to also announce his biography in brief. Dr. Shankar Barua is a distinguished scholar, practitioner, filmmaker, environmental campaigner, entrepreneur, and startup mentor with over 2 decades of multifaceted experience across academia, creative industries, and entrepreneurial ecosystems in both North America and South Asia. Born and raised in Upper Assam, Northeast Asia, he holds a PhD in mass communication from Texas Tech University, and he is deeply passionate about mentoring. His enthusiasm for teaching and mentorship has led him to design and deliver several programs that integrate storytelling, strategy, innovation, and business. His career seamlessly blends rigorous academic scholarship with hands-on industry practice. His filmography includes several critically recognized titles. I will put it in the chat box, but briefly, If God Be With Us, and I selected specifically from this session per se, Color and Save the Himalayas, and one of his latest cinematic venture, Blue Ocean, is set against the majestic backdrop of Dehradun at the foothills of the mighty Himalayas. Thank you so much, Shankar. We are looking forward to hearing from you, and then we'll open the floor for everyone to have Q&A. Over to you.
Thank you. Just allow me to share the presentation so that I can, so then people can. Mine is more of a campaigner's perspective. I really appreciate Renji actually making all that research available. And I think it was important that people understood exactly what it was in terms of the back-end research that folks like Renji. Is that visible now? Is the presentation visible?
Yes. Please go ahead.
Okay. So Renji already mentioned about our region, or rather the Himalayan region, being officially designated as the third pole because of the amount of ice that's there in the region. Now, my entire focus as a campaigner in the region is largely about the rainfall and the snowfall. We are concerned more about the decreasing amount of snow, a record low snowpacks, if I can call it, and of course, as Renji has very clearly mentioned, receding glaciers, accelerating glacial retreat. Now, this hydrological transformation that has happened, Renji kind of briefly mentioned about, and which is where our focus is as campaigners, is on the massive deforestation in this area. And please keep in mind that that has also aggravated, again, keeping in mind Renji's research that was just presented, that has aggravated record low snowpacks. Now, primarily, as was clearly mentioned in that research in the first presentation, our most important water resource or our reservoir is the glacier. Now, if there is an accelerated mass loss in that, in the entire Hindu Kush Himalayas, and even if global warming, as I mentioned here, is limited to 1.5 degrees, at least 1/3 of the region's glaciers will disappear by 2100, as Renji mentioned, and this is really, really alarming. So it kind of appears like, oh, now the glaciers are melting, there's a lot of water coming in, but that's not what we are primarily interested in. We know that with less snowfall, the underground aquifers are not actually storing the underground water that needs to be stored, and that will lead to, at some point, long-term scarcity. Okay, so there is a peak water paradox, as we say. Once the glacier passes its peak, its volume will shrink. I mean, it's but natural that it'll happen. Now, in terms of this was already mentioned, but I'm more interested, since I come from the Eastern Himalayas and from the Brahmaputra Valley. We look at these three. I'm just looking at these three river basins, the Indus, the Ganga, and the Brahmaputra. And of course, as he very clearly mentioned in this presentation, the entire snow dependency in these regions are, of course, different for different basins. While it is probably critically vulnerable for the Indus Basin, and it might not be so for the Brahmaputra Basin. As we can see here, it's moderate, but please remember that this the basin where I come from originally is plagued by a wet drought paradox. So there's an intense, and while I'm speaking, there was great flooding this just like 1 week back, what we call flash flooding during the monsoon, which is exactly what is happening now. Large parts of Upper Assam have been completely submerged and bringing great human and economic catastrophe to the region. So this is what happens, you know what I'm saying, when there is this paradox, but there'll be a lot of localized flash flooding, and then there'll be a large spell of drought. And now let me come to another important part, which is the groundwater, and he's mentioned about it. But I'm interested in the perennial springs, which is, as he mentioned, a lot of people in the mountains are directly dependent on that for daily drinking water use and domestic use and all of that. So while, as I mentioned here, while a lot of the media attention actually goes to the glaciers melting, which is but natural, and it's important that we focus on that. But it's also important to focus on the springs, the perennial springs and perennial underground water sources. Now, talking of the underground water sources, that's where the less snowfall part of it comes in, where we are really, I mean, it's okay to have rainfall, a lot of rainfall, but please keep in mind that if we do not have the snowfall that's required, and which is what's happening, there will be a large-scale, long-term a drop in the aquifers, in the underground aquifers. And as you can see, it's clearly mentioned here, the 25-26 winter season recorded a 27.8% drop in seasonal snow cover, which is like just recent, just a year back. And what is the consequence of this? Which is that it's leaving these underground aquifers completely unreplenished. And that is something that I think has been highlighted to some extent, but not so much. And so even in terms of the documentaries and stuff that are being made, we would like folks to focus more on the drying springs. This is exactly what has already been mentioned by Renji, that 50% of the springs have dried up. And then, of course, the snowpack connection, which is what I am primarily interested in, the constant drop in snowfall. Now, the long-term social economic impact, which is also what I'm interested in as a campaigner. As you know, a lot of people are leaving the mountains. There are ghost villages, all of that stuff. People are migrating. And these are particularly Kumaon. These are water-scarce areas anyways. You know what I'm saying? although, as he mentioned, 10 of the greatest rivers in the world kind of come out of the Himalayas. But it's important to understand that when people do not have a livelihood, the economic impact on their livelihood that makes them to migrate out of their areas. Now, I'll come back to my original point where I mentioned that this again is happening because of, he mentioned it, Renji, in passing, but this is one of our core areas, which is unplanned, haphazard development, massive deforestation, infrastructure development in the name of infrastructure development. Oh, build an expressway here, drill a tunnel, build a tunnel there. You know that Joshimath is sinking. All is not well in the Himalayas. This is exactly what we were trying to say. We rely on research by folks like Renji at IITs and elsewhere, but it's important to understand that our campaign, the public face of the campaign has to mention clearly that it is the haphazard. It's kind of like a very, it's a very obtuse, if I can say, development model that's not really working for people on the ground. People living in the mountains and relying on these springs and of course water from the Himalayan region. So that's important to understand. So please understand that now we are receiving a lot of, and I've clearly mentioned this, a lot of unpredictable rain instead of sustained snow. This cloud burst here, that there, flash floods. Why is this happening? It's important to understand that part. I mean, we cannot have this without, we cannot replenish our underground, our biggest water sources, the aquifers underneath, unless we have sustained snowpacks, sustained snowfall. That's important to understand. And then again, I mean, look at what's happening. What has all this infrastructure stuff done? In fact, it's going to be actually hazardous for these people as well, where they have massive hydropower ambitions, as we call them, like build Terry here, that there, build this hydro dam. Oh, let's harness the water from the Himalayas. Well, all that is great. As a political thing, it might work, but on the ground, Renji and others will, they will back it up with evidence saying that there are huge long-term consequences. Remember, the key word is long-term. We're not looking at what's happening today and which city will be electrified by a hydro dam in the Himalayan region. What's going to happen in the next 100 to 200 years? You know what I'm saying? By 2100, the glaciers are going to be gone. What's going to happen after that? So it's important to understand, and even at a very physical level, at a visible level, look at the landslide risks. You know what I'm saying? That's again another thing. And remember, the overall hydroclimatic stress that I keep talking about in the region has extended now to what we call a prolonged forest fire season. I hope everybody will understand that it's again because of the lack of snowfall and the moisture disappearing from the ground where we have these huge forests. That's the reason why. I mean, this is abnormal drying up, which will lead to an extended forest fire. And this is across the world. I really liked Renji bringing that entire global perspective where he showed about, you know what I'm saying? Look at the forest. Can you imagine the forest fires in France and Spain right now? Look at the temperatures in Spain and France right now. This is not fiction. This is actually happening. It's important for us to understand, the policymakers and researchers and campaigners like me, to understand that all is not well in the Himalayas. I can understand that the research clearly points out not a uniform pattern. Renji very clearly mentioned, thanks to Renji, that it varies. It varies. Of course it varies. Every region, every 200 miles to 500 miles, it will vary. You know what I'm saying? But overall, we are looking at an overall picture of what is happening essentially in terms of hydroclimatic stress. Like I mentioned clearly, my focus is on reduced rainfall and the retreating glaciers, reduced snowfall and increased rainfall. And very, very unpredictable rainfall that we lose that water. I mean, that's runoff anyways. That's going to end up as a flood somewhere downstream, you know what I'm saying? And like Renji very clearly pointed out, 25% of the world's population, please keep in mind, folks, 25% of the world's population, close to 2 to 2.5 billion people, are actually dependent directly or indirectly from water in the Himalayan region. Finally, I'll cap it off by saying mine is a very short and sweet presentation. I'm not a researcher, I'm a campaigner, but I rely on research by folks like Renji. What I'm constantly telling people is what happens in the Himalayan region is a bellwether for the rest of the subcontinent and for the world. Please don't forget that. This is the third pole. Thank you, ladies and gentlemen.
Thank you so much, Shankar, for bringing this out. And importantly, I wish to inform all our viewers here, and I see some of them in YouTube, that we have been really trying to bring our scholars and practitioners together so that we can get a better picture, and then we are not lost only in science, or we are not lost only in narratives, which are very well stitched in this presentation today. And all is not well. That was very clear out there. And I think the biggest worry both our speakers have raised to us, the decrease in glacier and the increase in rainfall. I also see two important aspects here when we talk about climate change. There is one is that the short-term impact the people who are right now living are facing, and then I will say the headache of the scholars and the policymakers, the long-term impact. And very powerfully put right now by Shankar, what if there are no glaciers by 2100? And Renzi was already talking about 40% of them will be lost, even if we succeed to maintain 1.5% of the Paris Agreement, 1.5 degrees, sorry. And these are some alarming things. And let us now open the floor for discussion, questions, and answers. And may I request Shankar to, yes, please close the presentation. And we can now take the discussion further. I am very keen to have some questions, but as a host, I will reserve my questions for the end to also do the vote of thanks along with it. So maybe questions or comments or concerns from our participants here. And meanwhile, I'll just also check at the YouTube space. Is there anyone who is chipping in right now? Okay, then I go first as the host of the session, and I would like to start, of course, with Renzi, and maybe get into your presentation where you were actually showing through the graph what it means that increasing of rainfall and its relation to the decreasing of glacier. Would you also like to highlight to people like us who live in the mainland, ordinary citizens, why me living in Ahmedabad, but by the way, right now I am in Germany, and as Shankar was already talking about the rising temperature in Europe, today, let me tell you, we are sitting at 30 degrees, which is, and I am in the middle of the ocean, by the way, in a wetland. What it means for mainland people when these glaciers are melting. Why should I be worried about sitting in Ahmedabad or Indore or, Chhattisgarh? These are the places I have lived in the past, or Kolkata. Of course, I know the relationship. Why should I be bothered?
Yeah, main thing is actually I can talk about the monsoon, right? We are actually still
Yes.
monsoon dependent place.
Yes.
Even if you are in southern part of India, we are hugely depending on monsoon. If you look into the long term average, annual average of rainfall we are getting is actually higher. I mean, it is not changing much, but the way we used to get in a very distributed manner throughout the year is not happening. Now it's happening. All rainfall is pouring in 1 week, 2 weeks, 3 weeks. So we are getting massive flood, and we are in other seasons we don't have water to manage, or even reservoirs are dry, we cannot make hydroelectric projects. So if you look into annual value, the value all you are getting is slightly almost same or slightly increasing also, but all coming together. So it is not about a Himalayan issue. It's a water, whoever using water from a reservoir or whatever the region, even in southern part, Bangalore is a good example, right? Why
Yes.
Kaveri issue is happening, it is not within the country is a conflict is happening. It's not, it's only reason is water availability in the river is going down. So it
Mm.
is happening in the same river during monsoon time, huge water is there, nobody wanted to stop it. But other season, low flow seasons, there is less water. So it is a concern for everyone. So with referring to monsoon itself, we can say many thing why other part of the world also be worried. So that is one aspect. Another aspect is whatever happening in the Himalaya is warming is happening not because of the emission happening in the Himalaya. Whatever,
Mm.
it's a part of the global system. Whatever happening in the northern hemisphere and whatever we are doing in the other part of the country, which is emissions, whatever the emission is actually happening. A good example is open fire of crop residues, right? We all know about
Yes.
the Delhi issues. Actually,
Yes.
finally, that if you really look into that, the error studies, this all getting trapped high in Himalayan region.
Mm.
Eventually, more energy balance over there is changing. More whatever the energy we used to escape, like long wave radiation, is getting absorbed by this kind of molecules and re-emitting. So this re-emission is getting more as the concentration of these molecules are more in Himalayan region. That is what actually triggering. So the
Mm.
problem is not the people living there is emitting. We other part of the world where is all kind of emissions are happening is actually finally making problem there. So it's everyone, we all part of the problem. So we need to, whatever possible way we can reduce, we need to reduce the emissions. So that is
Yeah,
one point.
very well put. And I kind of feel like, it's a give and take. So we are actually giving troubles, and in return, we are getting troubles in that sense. And because I lived in Ahmedabad for a long time, and last week it had 500 rain in not less than 48 hours. Water from knee length deep to even waist deep in a city. And of course, it is not only because of the rain. The planning of the city also makes a huge difference. But narrowing of the rivers, I mean, we see Assam, the way the river is swelling. So not considering the estuarine part of the river, that also makes a difference. But this whole water cycle, which we learn, so my questions are more like an ordinary citizens, a water student who has never gone to water school. And that's, please pardon me for these kind of questions, and I hope you can laugh at it, but that is how I would like to know these things. So in school, we learned about this beautiful picture of water cycle, and now we see how it is, so directly linked to, what is happening at the Himalayas and what is happening in the south of the India, where they are not directly linked as such geographically, if we say in that sense. So that makes a lot of sense to a person like me who has no clue of ABC of Himalayas. You were also talking about the declining Himalayan springs. So I got a bit confused in the sense, when we have more glacier melt, which I am assuming that there is more water coming out of the snow and ice. So in my common sense, I will assume that those water will also sit on those, springs, groundwater aquifer, lakes, and
Yeah.
also be there in the rivers. How do you link that with the glacier melting and decline of the Himalayan springs? What is the relation? So springs are only coming from the glaciers, so then they are reducing. What's the relationship?
Is that to me? Okay.
Yes, yes,
Yeah.
to you.
All right. So these springs are not only in Himalaya, everywhere. Springs are actually groundwater. Actually, it is whatever it normally in the mountainous place, whatever recharge happening in the upstream area, that water is going down and along the slope. If the elevation is less, that phreatic water, that means the groundwater which is flowing along the slope, which is coming out, that is what spring, right? That means somewhere water is getting recharged. So the meltwater, most of the meltwater is actually coming out through the channels, runoff. It is running away, it's not walking. So
Yes.
for snow, for glacier, so springs to be recharged, there should be more recharge. So we knowingly or unknowingly, we are actually covering many of the natural recharge zones of this mountainous place. Not only in Himalaya, more in Western Ghats, everywhere, people are not getting groundwater in the downstream area, mainly because the natural recharge places, which is valleys, some places in the valley, unknowingly we covering, and we are covering with concrete and all. So in Himalaya, this kind of developments happening. So of course there is more water because of melting, but that water is going like in a 1 or 2 days, it's going to the ocean. So the water, naturally the soil should have time to infiltrate, right? The infiltration ratio is very small, maybe like 1 millimeter per hour or 2 millimeter, three, depending upon the soil. Even the Himalaya, the soil type won't be having that much infiltration capacity. It's not like a loamy soil, right? So the water need to stand there. So it's not about water availability. It's about how small quantity of water it's allowing water to stand. So even it's naturally there is less chance for water to stand there because the elevation is different, elevation difference. So melt is happening, but melt water is going instantly to the channel, and channel is routing to the ocean and making flood wherever it's going. But in the same time, people, those who are actually living there, they should allow water to stand on the ground for some time. But nobody likes to see standing water, right? We allow water to go to our road or the. So this is actually a society's problem. No researchers, no government can solve this. Everyone should be
Mm.
part of the solution. You should allow water to infiltrate. So eventually, if you allow, for those who are living in the upstream area, if they allow water to infiltrate, the spring will survive. Nowadays, what happening? Monsoon time happening, water is infiltrating, and it is coming out. Only monsoon time spring is working. Or working means it is there. After that, no spring. That because the naturally the water table is going down. That is actually still water is there, but the elevation is lower than the actual spring position. So water is there, but it has gone down. But so, if you allow more water to recharge there, the phreatic water level, when it is increasing naturally, this same problem is happening in the coastal region. Why is salt water intrusion
Yes.
happening? Salt water intrusion happening because recharge is going down. Always where the salt water and the seawater is meeting, right? When there is more recharge in the land, the fresh water meets, and when the pressure, when less recharge happens, this pressure will be less, so more seawater pushing to the land. So that's what people are saying, seawater intrusion. The real reason is we all are not allowing water to infiltrate, and it is not, no government can solve this or no researcher can solve this. Everyone need to, I mean that it is uncomfortable to see water standing around your plots, but we need to allow. That is only, I hope you understood what I was trying to
Yes,
explain.
yes.
Yeah.
And adding to what you were saying, that we are not allowing the water to sit and settle there. One of the reason we don't like water stagnation and flood, and we are also the largest consumer of groundwater. So both are really making this situation even worse. Let me just go to Shankar now. You were talking about the primary frozen reservoir, referring to the glaciers, and you did mention about 3 points: the accelerated mass loss, the peak water paradox, and of course the GLOF, the glacial lake
Of
outburst
the,
floods. Go ahead. Yeah, sorry.
yes.
So
I just want to quickly go back
go
to,
ahead, please. Yeah.
if I might, I want to quickly go back to what Renji said, and I think it's important to
Yes,
understand,
please.
even as individuals, he really put it on us as a civic responsibility.
Yes.
So that sustainability and circularity are not just slogans. It also depends
Yes.
on what you do with your own lifestyle in terms of GHGs, meaning greenhouse gas emissions. He talked about emissions. Now,
Yeah.
how will the water stand if you're haphazardly destroying, like you said, covering streams, going on to do whatever construction in the name of tourism, all
Yes.
of that stuff in an expressway high. Can you imagine the kind of intrusion and human intervention in this area that is not allowing the water to stand, like Renji has just mentioned? That's why it's our responsibility, even as citizens, to see that even when there are societies or whatever, whether it's a town or a panchayat in a village, it's important for the person or people there to understand that this is a issue that begins with us. It begins with us about how we are, even
Absolutely.
in the village, or how we are planning to use our resources. And most importantly, what is our infrastructure plan, by the way? I mean, people throw this word around, this fancy word, infrastructure. Really? What infrastructure? Like destroying one section of the planet to build or whatever to do, so that other people can line their pockets. This whole development paradigm or model is extremely flawed. I just wanted to continue and put that across, going further with Renji. But I think there are a couple of people who want to ask questions. There is
Yes,
Jivika,
we are taking them now.
Vidisha
Yeah.
also.
Yes.
Yeah.
Yeah. So there is a question from Vidisha. Vidisha, you have put it in the chat box, but we are also very happy to actually have you with your video on. Go ahead. Yeah. If you
Okay.
put your video on, yeah, then
Oh,
it will be
sure, I
better.
can do that.
Yeah. Thank
Yeah,
you.
so my question is, say, if in a utopian world, say development and everything is stopped, say for example, kind of things happened during COVID, right? When everything was at a standstill. So how can the snow be built back over time? That's what I'm thinking.
That's an
Yeah.
interesting question.
So you're talking
I'm
about
sorry.
Research.
I
More
understand
research.
that we are all in this crisis, but say it's something, there was a divine intervention and everything had to stop. How and how long will it take for our snow to come back?
reconstruction. I mean, I don't. It will be very costly affair, even if you do in a small area, right? We are talking about changing the temperature. So maybe we can think about protecting whatever existing snow or glacier, right? Which is
Mhm.
from, there are many geotechnical solutions, that coir-based technical what you can say, fiber-based solutions, and all people are applying many places to
Mhm.
to strengthen existing or to prevent the melting. So that is only
Mhm.
one option. Reconstruction is actually, I don't know, I never thought of that, but it is not something like we are. It's a global issue. We are talking about the global temperature. Uh,
So,
Even if you
I
want,
understand reconstruction doesn't have to be human reconstruction. I'm just saying, say the water cycle goes like, here is a picture of the water cycle that my son has made, about all of that. And these are all these plate tectonics that he makes. So he is very interested in all this. So I'm thinking, naturally, if it were to happen,
nat-
how could it
yeah,
happen?
naturally it is happening on Earth's surface. You know all about ice ages, right? Ice ages are
Mm,
real.
yeah.
Every 90,000 years time, whole of Earth is getting covered by ice. Naturally it will happen based on the
Mm.
tilting of so by that time we won't survive. We are worried about our lifespan time. That's why we are worried about
Yes.
climate change, and
Yes.
so naturally it will cover. I think eventually in thousands of years, the whole Earth will be covered by snow. Again, next ice age will happen. So the
Again.
right now people are talking about this is a interglacial period. That means a
Mhm.
period between one ice age to another ice age,
Another
a
message.
warming period. It's a natural for Earth point of view, but
Mm-hmm.
never happened like this. The concentration of, for example, yesterday I am teaching this climate change course. When I was checking the every semester when I teach, I check the carbon dioxide concentration on that particular day. When I
Mm-hmm.
was teaching last week, it was 428 ppm. So you need to understand that even COVID time also, that is continuously increasing. That it's never happened even in the 8 lakhs years of Earth life. 8 lakhs
Mm-hmm.
years of Earth life,
Uh-huh.
never happened
800,000.
carbon dioxide concentration going high like this. But in the
Mm.
same time, we are blaming carbon dioxide as a but carbon, we cannot think about a life without carbon. Carbon
No.
is actually relatively innocent. Carbon dioxide is relatively innocent compared to global warming potential of other gases we are emitting. We always
Mm-hmm.
target carbon dioxide, but
Carbon dioxide.
carbon dioxide is very innocent compared to
So
methane.
now, here what they're doing is they're taking the carbon dioxide from the factories and then they're putting it underground
Yeah,
to,
geology.
lower the emissions in Southeast Texas, that where I am from. So
Yeah,
they're
they
doing
called
that.
us they called us geological sequestration. So
Mm-hmm.
that what
Yeah.
they capture it and they pump it to a lower aquifer. I mean, not aquifer, geological formation where it can trapped. Very expensive. During the
Mm.
process itself, half of the carbon emission happens.
I
Understood.
see.
So, and the natural
So,
way is natural sequestration is actually only plants can do. But again,
Mhm.
we can actually
That
that
goes
is
to
my
Shankar's point of reforestation and not
yes.
deforestation.
yeah.
And I think also it's about a matter of scale when we want to. I mean, we know that there has been a lot of experiments on creating clouds. If and
Yeah.
but the scale at which we are talking about is very different than what we can actually manage humanly. I think it goes back to the discussion that as humans we think that we can tame the nature and also fix it whenever we like to,
Mhm.
and that I think the tipping point has been crossed, and scholars around the world are hammering the policymakers that it's not no more possible that we can fix it. Let's go to Jivika because these conversations are very, very interesting and we can really flow emotionally on it, but we have to also respect the time. Jivika, over to you.
Yeah, hi. Thank you everyone for doing this. I have been living in a Himalayan village from last 8 years, and there are two things that I've been observing, and specifically when we spoke of the aquifer, because that's the primary source of water for us at the moment. So a little, connected that way. Um, one question around aquifers, wherein the aquifer is adjacent to the forest, yet the quality of water is declining or diminishing. So what are the things that I, as a citizen, or someone who's living close by, can do? Like, are there some kits that I can have for myself and keep testing the waters? That's one. Second is, how is the water quality declining if there is no construction or any activity happening at that side of the mountain? Hmm. Or from where it's coming in, that portion. The other question is around the Himalayan water system, like the water system which is called Kul system, which is used for irrigation of the farmlands. So there is essentially this glacier. Glacier said the water is coming down via a stream, and then there are some routes that this water can follow, and it goes across each and every farmland. So this is what a traditional gravity-based water system would be. Now, there has been a recent change in concretization of those water paths. Yeah, the channeling of sorts. What does that do to this whole system? Because essentially the idea is, if there's a road or something, if traditionally it was built with rocks, just stacking the rocks up in a certain manner and making it, channelizing it. Now those rocks have been concretized. So where does that put us, as farmers? What happens to these channels and how healthy they are? And my question can be answered by Renji or Shankar, whosoever, feels.
Okay.
Yeah.
So
Shankar,
at
you
a
want
Go
very
ahead.
grounded
Okay.
level.
Yeah.
Right.
Could you please tell if the water quality is changing means what way it is changing? What do you mean by water quality, or color is changing, or you are seeing more floating materials? What
There
exactly?
there is no difference per se in the water quality at the moment from that particular spring where we drink from. But it's
Uh-huh.
just that there have been some reports saying that water quality of the ground aquifers is no more the pristine Himalayan spring that it used to be. Now,
Yeah.
this particular one, I mean, it's just a hearsay because I have not tasted anything foul there. But of
Uh-huh.
course, the aquifer has been concretized in some manner. Besides that, there is no other major change in the forest above it. So,
Yeah.
if I say I have 4 aquifers around where I'm living, what do I do to protect it in that sense? Like, preserve it,
Yeah.
protect it. What do we do?
Normally we need to have a proper from scientific point of view, we need to really map these springs, and we really need to know where this recharge is happening. So I believe this is seasonal. Most of this, if it is seasonal springs, whatever recharging during the monsoon time is actually you are receiving, right? Everything under whatever happening in that recharge zone is actually going to change the quality of water what you are getting in the downstream. So as you said, it is only forest. I don't know the reason, but otherwise it will be naturally, it will be human reasons. Something might have been happening there in the natural recharge zone. That could be one reason why the water quality is changing, if it is really changing. And some of the springs will come from the depending upon the geology, it naturally come from the even confined aquifer. That means which is actually confined. Some are unconfined, which is seasonal. I mean, phreatic one. Under the some springs are actually coming out from the confined aquifer. That means which is trapped under the geological rocks, which is actually recharged some other place in
Mm.
one or two locations. Maybe there some kind of activities or something happening, or I don't know the really the quality aspect cannot comment, but this could be man-made reasons, only the one reason. And geogenic reasons also may be there. For example, these all we talking about aquifer. Aquifer is actually soil. Soil is actually chemistry, right? You can see these all compounds are there. The type of the aquifer material, the parent material, or through which direction it is coming, maybe that may be changing the quality of the taste, water taste, what you are getting. That may be one reason. What I'm speculating, okay, because I don't know what exactly
Yeah.
the reason. So, and regarding you are talking about the channels, means you are talking about drainage channels, right? When rain occurs, water safely used to dispose. Is that the channel you are talking about? In
Yes, yes.
yeah, the problem is earlier whoever lived in a mountainous place, they used to respect mountain, that topography. If you look into in southern India, this tourist places where the gardens and all, the road is actually constructed along the contours, right, respecting the
Yes.
mountains. And nowadays people, those who are, I mean, this is actually traditional knowledge, you can say. Even Britishers used to do that. And now we can say whoever having money, they come to this area considering this land as a tourist land, and without, and their only aim is protecting, saving money. They don't want to spend more money for constructing the way you are saying. They want to construct
Mm.
road laterally, without which money, the only aim is saving money for that project. So they have money and the sanction also given. So the
Hmm.
improper land management is the problem, you can see this happening. And again, we have regulations to stop it, but somehow they're getting permission. And
Right.
when government is doing, they try to do the road construction, still following the contours and all. We can see in southern, from south part of India, you can see in Western Ghats and all, many places landslide is triggering because of this kind of construction. Without respecting the terrain, they construct road like this, and next monsoon
Hmm.
time that will go. And finally that it will be triggering the tow region of a place, and the people living out downstairs will be getting killed. It is might be happened by a person who made a construction which is actually not supposed to do in a way. So similar thing, I think it's happening in Himalaya also. That's what you are talking about. The people are not respecting the natural drains, some kind of, no, naturally
Yeah.
when
What?
Himal
Uh,
yeah.
Sorry to that, but just saying, adding to it, these channels have been existing. They are just making it, putting concrete in it so that it just stays, I don't know, forever or something. Or when there's a lot of water coming down, which happens. It's one of the rain-fed areas that I'm talking about at the moment. It's wet temperate. The
Uh-huh.
water comes down really fiercely, and it might break these schools.
Yeah.
So concretizing it in that, by that logic, makes sense. But what I'm more concerned about is, because now this water is passing through the concrete. It's not no more passing through the rocks. So the
Yeah.
water that it is bringing to the fields is also, the water quality is going to go, decline. The
Yes.
nutrition will decline. Now, what does this leave us with? Like channeling channels for concrete, when we concretize the channels. So that was primarily the question, but I understand the road development and all. And the
Mm.
last bit was, if you can, little just show me the next steps in that sense, because I've been already living here and working on climate and farming, agriculture and all. I'm a permaculturist. So I wanted to understand, how do we take take into our own hands the water system of the region, and how do we maintain the serenity and the pristineness of the, whatever we have, and we have lots of it.
Yeah, let me just, can I
Let
just
me, yeah,
interrupt
sorry,
here?
Shankar.
Yeah,
I'll just add
yeah,
a question because I was coming to you to do this last question also. She
okay.
asked, what can we do at an individual level? Reminds me of David Attenborough's short documentary of 3 minutes, What Can I Do? But just to add to her question, thanks, Jivika, because you have really used a lot of creative ways to inform people and also mobilize people. Uh, how how can we really take it to the next level? And importantly, the way you are passionate about questioning the very development itself, what kind of development we need. So maybe that's also your last remark
Yeah,
also for the session. Yeah, go ahead.
yeah, thank you. I'm going to wrap it up. I really like Jivika's question because that's important, because whatever is happening, and like Renji pointed out very clearly, you're not respecting the terrain. You are imposing your own model on the terrain. So the idea here is that if human intervention goes awry beyond a point, you know what I'm saying, and then say, oh, okay, we have these standard answers, oh, well, nature is taking revenge and all that. Well, leave all that aside. Let's come to the table now and discuss what's actually happening on the ground. Look at what's happening in Chardham. I'll just come to something very basic. My film, Save the Himalayas, just clearly tells people as a public service announcement, do not litter the mountains. It's very simple. It has to start at an individual level. If you are trying to maintain the pristine serenity, I think the serenity word was Jivika, I'm not sure exactly, but if you want to maintain that, you'll have to inculcate from childhood a certain kind of lifestyle, be compassionate, be emotionally intelligent. I'm telling people again and again, if you're a tourist, do you mind being an emotionally intelligent tourist, a traveler who wants to go to the mountains? Have some compassion. You don't own these forests. You don't own these mountains, these rivers. But you want to go and enjoy, quote unquote, well, you leave them the way they are for you to actually enjoy the serenity and the pristine, whatever you're saying. So whether it is Char Dham, look at the amount of the tons of plastic garbage that is being generated every year. Who's going to clear that in the first place? So I believe like Sikkim, that's again a Himalayan region. Every panchayat, every village has to make it a point to make sure that there are no incinerators there. There's no way for waste disposal there. If I go to Machkhali today, which is where our registered office is, I was a little bitty startup, but I think Prakash Adhikari is also here from Machkhali and he'll vouch for it. Machkhali looks like Ghaziabad today. Don't get me wrong. I mean, there is no planned development model in that pristine area in Kumaon between Ranikhet and Almora. Why is that? Why is that people are selling off their land left, right, and center? You know what I'm saying? Without looking ahead for the next 200 years. Now, that's where people like you who are out there for the last 8 years, working in the area, like you mentioned, you are a permaculturist. So it's important that people actually engage on the ground. All the research that Renji and the rest of the folks do will go out of the window if we don't change who we are in the first place. I think that's the very first. I'm going to a school on Saturday here in Dehradun, Cambrian Hall, where I'll be actually talking precisely about this. This is the behavioral change that we are talking about. This has got, suddenly somebody comes in, like you said, concretizes who on earth would think about concretizing a original river channel? For what? I can understand, well, of course, why can't we leave a few places the way they are? Knowledge production beyond, it masquerades as knowledge production, but beyond a point, it's not knowledge production. It's just extractive endeavors at their best, where you destroy everything. You want to go to the ocean floor, you want to extract this, that. I'm glad that we only know 10% of what is there. I don't want to know what else. I'm not interested in giving biological names to species along the way. And this is an important thing. A lot of young people are waking up to it, not just here, around the world. We don't want anybody mining the ocean and saying, we're doing this because we are doing production of knowledge. I don't think so. But anyways, thank you very much. I really enjoyed this session. And thank you for giving us the opportunity to talk. And thanks to Renji for all his wonderful research that he brought to the table. And thanks to all the folks who asked questions and the people who actually joined. And so may I request you now to kind of close the session.
Yes. Yeah, thank you so much for this last, high point discussion. And I think for all of us, it goes back to this saying that all the studies are useful when we are having a conversation around it. And that is the whole idea that we actually started water conversation here at W4W, because the whole water management discourse is about how much can we extract and how much can we profit out of it. And that narrative to change, we need people like Jivika, as she was talking about, and many of us who have actually posed this question back and forth into the water space, that we need to continue this conversation so that the narrative that has been imposed on us is really questioned, and also it can be a small step towards bringing a change. We shall continue here. We are actually super blessed that we are booked until November 1st week. All weeks are booked. Next week, we are going to have Friday Waters Thesis Club on August 7th, which is Friday, at 6 p.m. IST, again from an international space. So we have to sometimes change a little bit of time. The session is on narratives of water security and a comparative study of China and India, looking at the water supply and everything. We will have Dr. Vidisha Srivastav talking about it, and we shall continue our water conversation as we have been doing for last 5 years. Once again, thanks to all of you, and thanks Renji and Shankar for this wonderful session. Lot of questions left unanswered, but that's the whole idea, that we open the discussion as much as we can and we really scratch our head left, right, and center to find what we can do. At the end of the day, we have to be the change we wish to see in the world and never stop asking questions from each other. Thanks, everyone. Please take care. See you soon.
Thank you.
Thank you.
You.
I see people are still joining, which I don't know how to deal with it.